day, and welcome to the first ever CIPP celebration that we're having here at UCT this year, celebrating the 50th birthday of cured-in-place pipe. The industry first major project happened in 1971. So with us today, and as part of our celebration here at UCT and throughout the year, we have 4 industry experts that are going to guide us through remembering the past, living the present, and pursuing the future of cured-in-place pipe. With that, I'm going to turn it over to my good friend Jerry Munchmeyer, who's going to kind of see us through this, shepherd us through this conversation.
Thank you, Robert. Well, welcome, folks. We've got Lynn Osborne. Lynn has been with the industry virtually forever.
Seems like it, yeah.
And we got Rich Thomason, same, and Ed Campbell over here, and I'm Jerry Munchmeyer. All of us have been in the CIPP industry, very dedicated to the CIPP industry. We've worked at putting a nice program together for this show, and we're here to do some overview of the technology. We feel that I think most of us were pretty much involved in the beginning of the technology in this country. Technology itself was started over in England, and I'm going to turn it over to Lynn for a minute. He's kind of our historian here, and give us a little on the starting of this in situ form legacy, if we may say that.
Well, thank you, Jerry. We're so used to saying Eric Wood invented cured-in-place pipe and propagated it all over the world. But it really wasn't that easy. Eric was an agricultural engineer. He was working for an engineering company that managed equipment for a mushroom farm, actually. And he was working on some trenchless type projects or products on his own independently during this time. And he had a friend, Brian Chandler, who was in marketing for another engineering company. And they would get together and discuss possible products and things they could do. And Brian eventually got him a meeting with Thames Water through the Greater London Council. And they just listened for an hour, 2 hours about the problems with leaky pipes that Thames Water had. So that kind of got the ball rolling. And following that meeting, Eric sketched out the first thoughts for cured-in-place pipe. As we know it now, early it was known as in situ form. So Eric made a sample in a clay pipe in his house, and they took that back, Eric and Brian, to the next meeting with the Greater London Council, and that sort of got the ball rolling after struggle. They had to struggle, though, to find a first paid-for job because they couldn't afford to do demonstration jobs. It was just 2 engineers, that was it. And they got that job in a London borough in 1971, and that was the first installation in an egg-shaped sewer, and then several more years of struggle to sell another job or 2 every month or 2, and eventually the engineering community accepted it, and as Eric Wood said, it just took off. But what we miss often in talking about this is it was a struggle. It didn't happen in a year. It took several years and the dedication of these 2 guys.
Thank you, Lynn. So over time, as they developed the technology over in England, I guess we here in the States got wind of it and started doing some research. I know myself, I was involved in a project, and the project involved a lining project or pipe replacement project in a very, very affluent seashore community, and digging pipes just wasn't an option. And so, we did some research. But I'm going to refer back to Rich here, who actually got involved even earlier than myself. Probably one of the first agencies that evaluated the technology when it came to this country. Now, just to continue on what Lynn was saying, because as Eric Wood developed it and started moving it, then he looked at licensing it, and he started licensing people around the world originally. So that's when I think, Rich, you got involved in it a little bit. So tell us a little bit about your experience. When it came to you and everybody saw it and said, what the heck is this?
Jerry, in 1978, one of the franchisees in Situform East, wasn't called CIPP back in the beginning in the U.S., they came to the Washington Suburban Sanitary Commission and presented in Situform the lining technology as an alternative. We were a progressive agency that looked at anything and everything that we could cost effectively and actually do reconstruction, we called it, of our sewer system, because there was such a big backlog, as well as there were places we couldn't get permits to be able to reconstruct the pipe. And so they came, our deputy general manager said, I think we need to use this, and came to me and said, all right, Richard, let's make it happen. So as I said earlier in a talk, I was a young engineer back then, 31, and so it was my responsibility to check it out. Never been really used out in the field, and they had done one job through a zoo over in California, and they had done one sample project for EPA, but the company, they didn't know about sewers. They knew supposedly how to mix the chemicals and how to do the wet out and how to, quote, install it in a sewer, but they didn't know sewers here in the U.S. So we worked with them and developed the methodologies that they needed to use, and outlined the different things that they needed to take into consideration. Again, there was by inversion, which means taking the tube, building scaffolding, have the tube go down, fill it up with water, have it invert the line from inside out, so that the smooth liner was outside and the felt impregnated by resin was up against the host pipe, and then you heated it to cure it and set it up as a new pipe. And so there were a lot of things that needed to be thought out and practicalities of how to do that. It was, again, cutting edge. There were a couple of standards that were very vague that dealt with what you would call cured in place pipe, but it didn't state that it was cured in place pipe, and some of the things made sense and some of them didn't apply. So we worked with them and worked it all out, and our first project was on Halloween night, October the 31st in 1978. And as I said, that was fright night because we didn't have a clue what was going to happen for sure. So everybody was frightened about what was going on. But it was a successful project. It went under a railroad, under a 4-lane state highway, and under about a 20-foot wide stream. And it was all done in one shot. It was very successful, and it's been reviewed and looked at through the years, and is still standing up as a new structural pipe inside of the older pipe, which was concrete, but was not stable and not structural any longer to carry the loads and the flow.
So to what I'm hearing you say, Rich, is that probably your agency was probably the major forerunner, even though there were a few projects done initially here and there, but once you got wind of it and started using it, you were probably the forerunner of the growth of the technology, because being with I believe you were the 7th largest agency in the country, and with you using it, I remember those days when, when your agency was using a technology, well, it's got to be good, and that's how some of the industry started growing. But before I get to you, Ed, I just want to mention something briefly. It was kind of ironic for me. I've been in the sewer industry for over 50 years. And I have to tell you honestly, before the development of this technology, the sewer industry was quite boring, okay? And there was no excitement digging up a trench and shoveling sewage-laden dirt. But what we found was that in the late 60s and early 70s, the whole emphasis on our society, at least here in this country, was on stopping water or leakage into systems. But then about 30 years ago, we discovered, well, these systems are getting really old, and it wasn't no more just the leakage problem, but it was also, we had to rebuild these pipes. And so the introduction of the lining technology and Citriform process was almost like coincidental with that. We needed something new to rebuild our infrastructure, and here it was. So the timing was pretty appropriate, I think, and it's proven out since the industry has grown to a great extent.
It's definitely proven out, and again, we used it, and it was the springboard for our reconstruction program for sewer and for water. We used this technology, the cost effectiveness, the environmental savings, the disruption savings, again, communicated to the community and to the politicians who approved the budgets and so forth. It set WSSC on the roll to have a reconstruction program, which today runs between $60 and $100 million a year.
And that's just one agency.
Yes.
I mean, you multiply that times, let's say I don't know what position they are in the size in the industry today, but you multiply that times the number of agencies in this country, that other agencies are in the $100 million range and so on, that cumulative, there's a lot of work being done, okay? And very, very important. And Ed, question I'm gonna ask you is, Ed, you're more technical in the sense that you get very much involved in the design of these systems.
That's correct.
Because it isn't just simply, well, we did initially, we just threw a liner in the ground, okay? I mean, that was the initial technology. But over time, we developed standards and we started following rules and whatnot. And so all of these systems technically get designed. There was not one size that fit all, even though in the beginning, that was kind of the concept, that one size fits all. So Ed, tell us a little bit about how that came about, where we started developing design formulas, and you're involved in actually updating that right now. So can you give us a little insight on that?
That is correct. Well, I think, like you just said, Richard, you were using it in, what you say, 1978, but the actual design method was not even presented until 1989, so because Citriform was the leader at that time, and because for a long time it was a proprietary technology, and a lot of times that's the way technologies get going. Somebody has a creative idea, it's really good product, and it just has to be allowed to grow until others see the need to get into it, and that original patents start running out. But the design technology that we had, we didn't really know how to design it. We didn't know if we wanted to design it just simply for the buckling pressure because of the groundwater that was acting on it, or if we needed to do something greater and actually design it for a standalone structure. And I can tell you personally, I put a lot of in situ form in where there was no top half of the pipe there, so, we were really kind of pushing the envelope there because the industry hadn't caught up with the ability to fill the voids on the outside of the pipe and what have you. But I think you're probably referring a little bit to the talk I gave this morning at the conference, and that was that, originally there was two schools of thought on how you would look at whether a pipe would buckle under that external hydrostatic pressure. And one that is touted a lot in our industry is by a gentleman by the name of Timoshenko, who did it way back when, I think. But basically, he took a thin, long tube, submerged it, and found how to calculate the pressure that would make that tube buckle. But that's not what we were doing. We were actually trying to line a pipe that was in a pipe. So we had something that was actually helping restrain and actually strengthen the CIPP against buckling. But unfortunately, the German gentleman who figured that out in 1977, well before this design procedure came about, spoke an obscure version of German, and so nobody knew how to read his work until in situ form years later hired a gentleman by the name of John Gumbel, who was able to look at it. And then things started evolving in our industry to try to, we knew we had a start, but we wanted to get something that was more accurate, that would be more predictive, because even though it was really a little bit slow here in the United States for the product to grow, it's kind of like when Richard was talking this morning, when they gave in situ form east that 24-inch line underneath the trifecta of a railroad, a highway, and a stream, they were trying to give them their worst line, and they decided if it worked there, it would work anywhere. And Richard, that was a theme that was repeated by a lot of cities, because where I came to know in situ form was I was a consultant engineer right out of school, and then I went to work for Little Rock Wastewater Utility in Arkansas. And one of the first challenges I had, because we'd been through this era in engineering where everybody was about getting rid of your leakage in your pipes, and we decided we weren't being very successful at getting rid of the leakage in our pipes. But my boss said our number one priority as a wastewater utility is to transport and treat. If that pipe's not able to transport and treat, we're in trouble. So we were on a very aggressive program to make sure that our pipes were structurally sound and able to transport and treat. And so one of the first projects, I don't know if you even saw this one, Lynn, but it terminated under a 10-story building. The manhole was literally in the basement of a 10-story building, and the entire city block in Little Rock, that 10-inch pipe went under it. There was not an option to dig that up. We really had to look for some way to do it. And then the CIPP made that happen. They made it work for us. And I had another project almost on the heels of that, which was in an alleyway behind a city block in downtown Little Rock, that it had so many electrical cables and phone cables and communications cables and concrete cradles over it, and not to mention the fact that we were flooding the vault of a bank. And so we were told if we made their money dirty one more time, we were in trouble. So we tried letting it out for bid, and nobody would dig it. So we were forced to line it. It had 32 service connections on it, of which only 2 of them were still live, because Little Rock was an old city. And there'd been a lot of stuff that had been on that city block over the years, and everybody got a new service connection when they did it. But I think really, as we're talking about design and we're looking at stuff, I also said that really, I think when the design procedure first started, we were really trying to concentrate on 8, 10, and 12-inch diameter pipe, because 95% of the piping in the country is that small pipe. Not that there's not a lot of big stuff, but that was where the pipe was. So the design methodology was really kind of focused on rigid, small diameter pipes, but we weren't being complacent with it. We wanted bigger pipes to be designed. And in fact, Lynn, you showed a picture in Little Rock, Arkansas, of a project that was done in, I think, 1984. I think it was 84, or 83 or 84. 87?
87.
87, okay, so that was near the end of my term with Little Rock, but what had happened was we had multiple 60-inch diameter pipes. They were 40 feet below the ground surface, of which 30 feet was true water. And it was so bad that we would regularly monitor the tops of our manholes, because if one started to sink, we knew we had a problem. We knew we had a serious problem. And to make matters worse, the city of Little Rock's airport was a very viable moneymaker for the city. And so they decided in their infinite wisdom, they were going to build all the ticketing and check-in over one of our 60-inch diameter pipes. And so, and it went right along the ramps, and I sent a crew out, and they were measuring the height of the manholes, and they came back, and I said, well, you're 18 inches too low. And they said, no, that's right. I said, go back and check it real quick, will you? And they went back and checked it. It was down. And what we found out was we were sinking, and we actually had a pipe that went underneath the ramp where American Airlines parked, where there was no more soil because 2 pieces of pipe disappeared at 40 feet. We don't know where they went. So we had to do a solution.
Let me put that a little in perspective, because for one of the reasons this technology is so invaluable to our industry is that the underground infrastructure, number one, is, I always call it the forgotten infrastructure, simply because it's the underground. Nobody sees it. But I've done some evaluation of the underground infrastructure that tells me that the value of the underground structure probably exceeds the value of the above infrastructure that we typically talk about, the highways and the buildings and the bridges and things of that nature. So the other thing to put it in perspective is why you did all of those things was because we usually put a life on materials. They're useful for so long. In the case of sewers, and I've designed many over the years as an engineer and in a consulting business, but we put a 50-year life on a system. And much of the infrastructure in this country is much older than 50 years.
I'm not even sure they put 50 to start with, because they didn't necessarily think that was going to remain.
Well, originally, I don't think anybody had any criteria.
I know.
agree
They just
with you.
built them.
But when we started really, even back 30, 40 years ago, we did put design factors on the design, because that's what I was doing in those days, mostly design.
Okay.
So when you think about it and you take the time that you look at a lot of these pipes, and they're 100 years old. I was a city engineer for a city up in Massachusetts, and we had old brick pipes that went back to the 1800s. Well, they were way over their lifespan. So again, just to give perspective to what you were saying, a lot of pipes are failing. All kinds of scenarios, whether it's pipes sinking or manholes sinking or pipes just totally cracked and broken up. It gets exponentially worse every year as we age the system further.
Well, actually, Jerry, these pipes were in really good shape. They were concrete pipes, concrete cylinder pipes, in fact. The problem only was with the joint integrity. It's the joints that could go bad, and in fact, it scared the bejesus out of me when we were we were walking, but bent over. I was a lot taller back then, and these guys would try to stab the joint and test it with a screwdriver and said, please don't while I'm underground here with you, because the manholes are 750 feet apart, and I don't run that well on my legs. But yeah, you're right. But the point being that I was trying to make about that with respect to your question about design was, here we were now going to be doing a 60-inch pipe, and because of the design requirements that we had in that 1989 design method, I needed to make that 60-inch pipe 30 millimeters in thickness. So, and because of the on top features, the access to it, I had to be able to do 2,000-foot pieces one at a time because I had to go underneath runways and I had to go underneath buildings. And at that point in time, we didn't have the ability to turn on a pump and it would just throw the resin in there. We rented a refrigerated warehouse in Little Rock, Arkansas, and we put a bunch of 55-gallon drums in there, and Al Cothorpe, the engineer, personally measured out each one, and like you, Richard, they had to mix each drum, carry them in a refrigerated truck to the job site. We're over the hole, and we're pouring this resin into our felt tube to try to make this liner work.
But Ed, I think that Little Rock job, I was on that job, it just shows how fast this industry developed. You were doing 2,000-foot shots of 60-inch, 30 millimeters thick.
Right.
3 years before that, a 24-inch was an accomplishment.
Yeah.
And that's just how quickly it expanded. And we had problems along the way.
We did.
But we lived through that. So.
But I think like you were saying, Jerry, because of the need with so many cities, and just like with Richard, the group that he worked for, they realized this was a tool and it was worth investing in. And in fact, my manager at Little Rock Wastewater said, we're the biggest wastewater agency in Arkansas. We have the money. We owe it to the industry to check out new technologies, see how they work, take a little bit of risk for the industry, because good working tools are gonna make this industry work. And at that time, I would say we only had, but we had 1,000 miles of sewer line in our system. But that's what Jerry just went to say, is the miles and miles of underground infrastructure, because we now know today that when we're talking about the big pipes, that the little pipes, the lateral pipes, probably eclipse the volume of pipe that we've got, and it gets harder and harder every day to dig these up. Right. So the trenchless technology is the technology that's making it work, and CIPP has grown in so many areas because of the innovation of the people doing it, I think.
Absolutely. I think the industry's grown. It's gone from an initial installation in 1971 to where we are today. That's why we're celebrating 50 years. It's 2021. So it's an achievement. And part of the discussion here is that when we design for underground infrastructure, we want to make sure we get a product in that's going to last. And so the proverbial question has always been with the cure-to-place technology, how long is it going to last? And we've traditionally, by the seat of our pants, have said, 50 years, it'll last 50 years. Well, we've been absolutely verified today. We are in a 50-year life. The technology is a 50-year plus product. And it has saved this country, if not the world, a huge amount of money, because the cost difference between digging and not digging is very big. So with that summarizing, let's talk a little bit about today, okay? Where are we today in terms of the technology? Lynn, you want to give us a little overview of your thoughts on that?
I think, you went over them in your presentation this morning, but
Right.
Materials. We now have resins that are cured-in-place pipe resins. We have polyester resins. We've got vinyl ester resins. There's always the issue with chemicals and using chemicals, and styrene is a big component of our polyester resins, and styrene has a very distinctive odor. And there are questions about styrene that are being answered, but now we have vinyl ester resins that don't use styrene. So it's just another advancement. We've got epoxies now. That epoxies were always suspect because they had a very short pot life. They were hard to use. Well, now we've got long pot life epoxies. So we've got all these different resins. The tubes, oh my goodness. We've got tubes that are all glass. We've got tubes that are reinforced with glass and carbon, or glass and carbon. We've got pressure tubes, we've got gravity tubes, we've got polyurethane coatings, we've got polyethylene, polypropylene coatings, all of these different types of materials that are used. Installation techniques, different curing techniques. The light cure has made a big entry into the United States and Canada in the last 10 or 15 years. Water cure, it was the staple for years and years. Then steam cure came along. Steam cure is dominant in small diameters now. So I think those are some of the things, and also the shift in the market, which is shifting now to more pressure pipe.
Okay, so what I'm hearing really is that the industry, even though it was born many years ago, we're at a point we feel pretty comfortable. It does what we say it can be done, what the design says it can be done, and it's probably one of the most viable ways of rehabilitating the underground infrastructure. Any thoughts on that, Rich?
Yes, the first lines that we've done are still standing and still in good condition and still transporting the sewage through them and are still standing up structurally. And so it shows that all of the advancements that we're making, more testing, all the different materials, that the original product was still good. I mean, 1978 was the first lines that we did, and we're approaching 50 years, and we can say in the U.S. they stood for 50 years. They only got to make it a few more years to get there. So with all the advancements, we can even have more confidence and more a good feeling that yes, it will be a 50-year life. And back when we did it, we were saving money. It was half the cost of open cut construction, not even taking into account where people will assign environmental savings and savings from a customer traffic standpoint, disruption to businesses and all of that. And that it's more savings than that now because of the advancements that have been made.
Yeah, and let me, maybe if you remember, I think you were involved in a project with the EPA not too long ago where you actually did some investigation here in this country of existing pipes that were in the ground for a number of years, and you tested those pipes. Can you give us a little update on that?
Yeah. It actually, I think it's a published study that you can get online, but the US EPA wanted to know if these systems were actually going the distance. And so the project team that I was on was assigned to actually find unique applications around the country. We picked some, one was in Columbus, Ohio that was installed in 1992. We did the 36-inch in Denver, Colorado, I believe. And where else did we go, Lynn? Because you remember the ones we looked at? I know we looked at many.
We did, but Columbus and Denver were principal ones because the Denver pipe was over 30 years old, if I remember right. Yeah.
And the nice thing about what we saw in that was, like Richard said, we did one step further. We didn't just look at it. We actually crawled into the pipe and took a sample out of the wall and took it back to the lab, and we tested it to see if it had the properties today that it was purported to have had when it was originally installed. Right. And we found that they did. We found that there had been no loss, with respect to the physical properties that they had been designed for. And I think that same held true on the ones that have been installed in the UK. They found that they tested those. And so that really helped us as engineers feel really good about, we knew that structurally we thought we were being conservative, but still we needed to know that structurally they were surviving. But we also wanted to know if they could survive in the harsh environment of a wastewater treatment system. Because, sometimes they're the good wastewater that you know about, and sometimes they go into some ugly areas where the industry is that, can really challenge the longevity of the pipe. But because we've had, the various resins to adapt the CIPP process for reconstruction to those various areas, and what we measured showed that they were indeed there. And in fact, we even found that where we exhumed some barrel samples, we found that the barrel sample was still watertight. And that was a really important thing. There was no porosity in the barrel itself. Even when we had one of them, I remember, we always said that the coating that was used during the installation process for wet out saturation and for the inversion process, we didn't expect it to live forever because we knew it was of a material that would probably naturally degrade on its own. But the real structural pipe, the pipe that we wanted, was in that polyester felt tube. And all we had left on the one in Columbus, Ohio, was the little fuzzy hairs where the coating used to be. But other than that, it was as strong as it ever was and still performing as good as it ever was.
So just thank you, Ed. And so basically what I think we're all saying here, we've got technology, it works really well, but I also question a couple of things. One, it was a technology that was developed by specific companies under certain patent agreements, and the quality was very, very closely monitored and whatnot by the companies that had these patents, whereas today the industry is a commodity industry, okay? And we need to talk about that just for a second, is some of the things that are important today. We have great technology, it works, the resins are great, we've talked about that. The only other thing I can think of is we still need to really develop more educational tools in the industry. I think there's a somewhat of a lacking. There are some which I can talk about. We have inspector training programs, we have educational programs, but I believe, and I'm going to ask each of you to give me a comment on that, is what else do we need to really kind of put the lid on this and get good continuous quality work, okay?
Right.
Because the industry has grown, and like any industry, there's always been corners cut and work that was cheaper because somebody tried to get the work as opposed to somebody else. And I think we've grown to a point where we think it's a great technology and we need to support the fact that we want quality installation. So anybody want to give me an input on that?
Sure. I would say that I think, and Glenn would probably chime in here, I believe the resin manufacturers who are supplying the resin, as I think you said just a few minutes ago, we have resins that they know are designed for CIPP. And so these resin manufacturers, they have skin in the game to produce quality resins that are going to do what they need to do. And I think when it comes to tube manufacturers, the manufacturers that have evolved and become more available have followed with the learning process that the earlier tube manufacturing companies did. I think the biggest issue with respect to maintaining the quality, and you mentioned it when we talked about, the training course for the inspectors, is that there is such a need for this product, and the contractors are growing at such a rapid rate that getting quality training with the crews so that they do the job right in the field is probably the biggest point right now. There's a lot of knowledge out there, but then there's also a lot of people that don't really know necessarily every point of what they're doing.
So I think what I'm hearing is we've got a great technology, we have great materials, but we need somebody during the installation of the materials to make sure they are the correct materials being installed, since I just said it's a commodity industry and you can substitute materials fairly readily unless there's somebody checking to make sure that those correct materials, those good quality materials are being installed.
Right.
Richard?
Correct. The industry needs, first of all, good specifications. because
Right.
if you don't have the information in the specifications, then they can supply something that looks like it, but it's not going to stand up. As well as you need the inspection. And that's been the biggest problem I've seen all through the years. WSSC, we did inspection and trained, and we had it put in right, and it stayed. But people have gone away from inspection, full-time inspection, and you need to have them trained properly, and you need to have them on the job and seeing everything that is done.
That's what we
So-
found, Richard, in that study, was that the specifications called out for the testing and called out for the monitoring of the quality, but the owners were never executing on that part of their contract. They were falling down. They just thought it was so simple. You know, it's one of those things where we said it's so easy to install, not that it's easy,
Right.
but you know what I mean? It's so much easier than open cut work. They just assume that the quality follows suit, but it doesn't. And it does take a watchful eye on the part of the utility. One of the challenges we have with our industry right now is there's still a great deal of innovation going on. And that presents a problem when you try to write a specification.
Right.
You know, because you almost need to write more of a performance specification than a prescriptive. Because like you mentioned today, that the resin that you first used, they were judging by a flexural modulus of 150,000 PSI.
Right.
And what was written in the ASTM standards was 250 when the material was clearly capable of 400.
Yeah.
And today we've got resins with their resultant tubes that are pushing 2 million PSI. And so I always have a little bit of heartburn if an owner, puts too low a mark on what the value should be. The value should be what that particular product is capable of achieving based upon the testing that has occurred. And then you need to make sure that the performance of the installation delivers on those values. So it's really complicated the engineering community a little bit, and Jerry was always a big proponent of performance specifications. You don't get wound up in specifying this number or that number as much as you want to lay out what the owner wants to see at the end of the day, what they want to be able to take away from that job, which is if they want a 50-year life, then you want the different technologies to have shown what their testing shows will deliver a 50-year technology, and that you want to know that the contractors are trained in how to put it in a way that will give you that 50-year life. That's a real catch-22, and where the industry is at is because we're afraid to train people. We're not afraid to train the inspectors, but we're afraid to train the actual guys who put it in per se. There's no union hall or anything like that where necessarily they train them, but that's still an area, because I've personally been on job sites where a guy told me his truck couldn't achieve this level, and I said, well, when you get finished, let me take it over. And when I'd take it over, I'd turn a few knobs on his truck, and all of a sudden he was making hotter air than he'd ever made before. And he said, how did you do that? And I said, I just read the owner's manual on the truck.
Well, you're kind of substantiating that education is absolutely
really
necessary
absolutely critical.
at this point in time, okay?
Yeah.
We talked about how we got here, and we're here, but being a commodity product, we need
how to go forward.
We need to button up on that. Lynn, you want to answer?
Yeah, it's a knife that cuts both ways. It was great that we grew so fast and were able to rehabilitate, reconstruct so many sewers, but now that we're here, it's a commodity process, a product, and trained inspectors a necessity, but we have a lot of crews that are never
Absolutely.
trained.
Correct.
And I don't care how good the inspector is, if the crew's not trained, that's, you've got to have both. And that's a real challenge, because I've been out there too, Ed, just in the last 2 or 3 years watching crews with some of these studies that NASCO has done with Trenches Technology Center. And there's a lot of different techniques used in the field.
Well,
That's a nice word.
Well, generally, the technology has a prescription on how it should be installed. Usually a manufacturer, they may vary from one manufacturer to the other, but it's, what kind of resin, how long do you cure it, how long do you do that, and then how do you install it and whatnot. And I don't know if you all see it, but I don't see that always being followed in the field. I see a lot of installers are taking their own license on how they think it should be installed. Sure. And I've always been an advocate, if you, and this is proven true over the years, if you follow the recipe, even if it may take you a few minutes longer, ultimately you will have less errors and less repairs to do, and you will make more money. And it just seems to me that that theme has to still be ingrained in the industry to a great extent.
Correct, I agree with that. But here's the other problem. Because the industry has grown so fast and is continuing to grow so fast, where it really has a head-on collision is with the people that are installing, providing the liners, have the crews. They don't have time to train the crews correctly. They just need to get the jobs and get it done. And at WSSE, when the patent went away and everybody started getting in the game, we had specific things that they had to do. If you wanted to install a liner, CIPP and WSSE, you needed to come and do 3 trial shots with us at your expense, and we made sure that the people knew what they were doing. If they showed up, and we had, believe it or not, we had one company show up with a liner based on that it was an 8-inch line off of the as-built, and installed the liner, and it wasn't an 8-inch line, it was a 10-inch line. They didn't even measure it, so therefore it failed. I mean, it's like, you're certainly not going to give them any work. I mean, so you need something
So
like
I think
that.
what you're saying is, what you mentioned earlier, specifications really become paramount.
Yes.
The engineers have to write good specifications, not vague specifications, not specifications where they assume the contractor knows what he's doing or what they're doing and that they're going to do it correctly each time. It has to be very specific on what the deliverable has to be at the end of the day, and the contractor has to meet that, or it's not going to be acceptable, very much like you did
Right.
at WSSC.
Yeah, I mean, some people would put in their specs, you've got to have lined 20 miles of pipe to be able to bid on this job.
Right.
That doesn't mean anything.
Doesn't mean
They
anything.
could have installed 20 miles of pipe incorrectly. So,
Well, you could have a whole crew of untrained people,
Yeah.
even though the contractor may have the experience.
Right.
Right? So the people are just as important as the contractor.
absolutely.
So, okay, we're pretty much going to wrap this up shortly. I would like to talk a little bit about the future, since we've talked about where it came from, where we are today. I see it, my own impression is the industry is going to continue growing. I think the key to growth is going to be upping the quality level to some extent. I think customers today are realizing that cheap is not the best way to go. You want to get a quality product that's going to last. Any input, Lynn?
Yeah, I think the gravity sewers, I think there will still be innovations, but to me, that'll always be the bread and butter. That's what pays the bills in a lot of these installation companies. Gravity sewers, it's not very, it's not considered the high-end work, but it's a bill payer. But there still will be improvements. Pressure pipe. Water lines are coming to be now. That work, there'll be more improvements. But, we saw a presentation this morning on gas. And I mean, I was pretty impressed with what they're doing in gas lines now. So I think, that market's going to continue to grow. I think the big growth, gravity sewers are going to continue to be there and grow some, but we're going to see in the pressure market more growth.
And I think that, like we heard this morning, this new ASC manual of practice is going to result in more practical wall thicknesses, which will take some of the fit and finish errors out, because sometimes in the design phase, we have made it harder for the contractor to be successful at fitting into the hose pipe. So if we can be a little bit more on the money on what the thickness actually needs to be, and it makes it an installable thickness, we'll actually get a better reconstruction than we would under the old method that we were using. Not that it had anything wrong, it's just that, like you just said, Jerry, we've grown to a point now where how is it going to take us forward? And I think that's going to help the contractors with their installation. It's also going to help some cities be able to do even more with their money than they could do before, because we'll be able to do at a little bit thinner cross section, but yet a more conservative cross section than we even knew that we were doing. So I think that and I also agree with Lynn that the gravity design is going to continue to lead us, but now we're starting to focus pretty quickly here on the pressure design, because the pressure design also needs to catch up with the industry as we go into it, and it varies by the type of application. Force main pipes have a lot of stop and start, which means you have surges in pressure, but water mains are pretty steady state. So, but they have their other deals. But I think, we're still in a very early growth, and we've got so many more gravity pipes to do.
Well, this kind of brings me to the point of we need to expand the training, including engineers and inspectors, but also the contractors, especially when we get into pressure pipe and where it's really going to be much more critical to do all of the phases of the installation, and the preparation have to be much more correct and almost near perfect, because you're in a pressure situation. Last word, Rich?
Definitely on the pressure pipe, the training, everything has got to be 10 times what it was for the gravity.
Yep.
Because if you have a failure in the gravity, it's not good. It's an overflow, a discharge of sewage in the environment. But when you have a failure in the water system under pressure, we're talking about devastation.
You're talking about a geyser.
Tremendous amount of pressure and water and damage and loss of life that could take place in those situations.
Okay, gentlemen. Very good. Thank you.
Thank you.
Thank
for
you.
participating.
And that wraps up this year's 50th anniversary CIPP celebration. I appreciate these gentlemen lending their valued history, insight, experience, and sharing that with the audience. For Underground Construction Magazine and UCT Conference, I'm Robert Carpenter, the Editor-in-Chief. We appreciate you watching, and we really appreciate these gentlemen and what they brought to this presentation.